excited. I suppose my presentation may be a little bit different from some other presentations. I'm going to try and give a bit of background as to why there's a growing interest in this space and some of the research that I've been doing. So I guess, what is mixed species cropping and why do it? So it's known by many names, and the more fashionable it becomes, I'm sure it'll end up with lots more. We tend to like to coin our own names for things. I'll be referring to predominantly intercropping, which is growing two crops together. So two grain crops with the purpose of harvesting the grain. Pasture cropping, which is growing a crop and a pasture together. Overcropping is another term that's used, where you're generally sowing back in over top of an existing pasture stand, generally a perennial pasture stand. So for example, a loosened stand that you would then sow into. Companion cropping is another term that gets used a lot interchangeably with intercropping, and that's where the design of the intercrop is really around creating synergies. And this is a term that's often used in regenerative ag, where they're looking at pairing together different species mixed with the idea that they will provide benefits to each other. There's also multiple ways you can configure an intercrop. And as you go through, I think you'll get the sense that these systems aren't straightforward and they're not the easiest systems to work with. So there's multiple different configurations. The main three that we see is what's called double skip row arrangement, single skip, and mixed row. Double skip is kind of your gold standard in research. We know that the double skip row arrangements, when we're looking for maximum yield benefits of pairing together species, we tend to get it on our double skip row arrangements. This effect, though, in my more recent work, drops off in certain scenarios. So double skip is normally considered your one where you're going to get maximum return for in that scenario. There's less interspecies competition. It's, however, one of the more logistically challenging ways of doing it from a grower's perspective. And then you come to the two that are more commonly adopted by farmers, which is your single skip row arrangement and your mixed row arrangement. So that's probably just to keep in the back of your mind. And hopefully the images there give you a bit of an idea of what these systems actually look like in a paddock. So the idea of intercropping is to grow two or more crops on the same piece of land with the aim of increasing productivity, reducing input costs, capturing those rotational benefits, particularly where you can see in those images we've got a pulse crop and an oilseed crop. So those benefits of nitrogen fixation, weed, pest, disease breaks, this is dependent on the combination. Risk management strategies, environmental and soil health benefits. So intercropping isn't a new concept. It's been historically practiced in smallholder farming systems around the world. In Australia, it's not new either. A review of literature, you'll find references to intercropping dating back 20 years and beyond. As a child involved in farming, the practice of intercropping and pasture cropping, overcropping were things that growers did. So what's changed? Like, what's new in this space, and why are we suddenly starting to see an increase in the adoption? If it's always been there, ticking along in the background, what's changing? So through this presentation, I'll try and address those two questions. So what's changed and what's new in this space? So I guess we'll start with, what do we know? So mixed species cropping is a more complex system, and it requires adaptation from our current monoculture system. So in Australia, cropping is very focused on monoculture systems. Even some of our pastures can lend themselves towards being a little bit monoculture. So I suppose that's something to keep in mind, that we're looking at changing the system from just one plant species to more than one. So a recent review of research done by CSIRO showed that, so they went back and trawled through a whole heap of historic intercropping trials, so intercropping being grain combinations. And reviewing that literature, they found that on average there was a 12% yield benefit from growing a wheat or a cereal and a legume intercrop. But when they then looked at where trials reported yield data on pulse and oilseed intercrops, the average yield benefit was 49%. Now, I don't know too many farmers who wouldn't take a 49% yield benefit, but the story needs to be unpacked a little bit more. So we do know that there's adoption of these systems in broadacre agriculture in South Australia. We tend to see the majority of it, or the stuff I know about, the majority of it is in our lower rainfall environments. And there's growing farmer interest in this space. So this is a demonstration of some of that farmer interest in this space. On Monday, I was on the Eyre Peninsula, and I spent a day with growers just looking at intercropping paddocks. To put it into context, I decided I was going to do this. I advertised it on Twitter. They had a week's notice that I was coming over. The only platform I advertised was on Twitter, and I had 14 growers roll up for this day. That was purely looking at one topic, which was intercropping. All of those growers were intercropping. So I think there's a lot happening out there that we're unaware of. Some of those growers, it was their first year of trying it. Another grower there had been doing it for 10 years. So why were they doing it? And this is, I think, one of the challenges behind the system. It's not a one size fits all. They're all doing it for completely different reasons. So the grower in the top left corner, where you can see everyone standing around the ute, and then the following top image where we're looking in his paddock, this grower's been dabbling in this space for probably 3 or 4 years now. And he's really looking at it from the holistic benefits, as well as trying to get better coverage across his paddock. So one of the challenges for his landscape is that there's a lot of soil type variation across his paddock, and he might get really good establishment of, this is a bean and lentil intercrop. He might get really good establishment of beans in some of his paddock, but not in all of it. Conversely, the lentils will get good establishment in some part of the paddock, but not in others. So he's wanting ground cover across his whole paddock, but can't achieve it with just one species. So that's why he's looking at that system. Down in the bottom paddock, on the left-hand side, you can see an insert there. That's, again, a bean and lentil intercrop. But again, this farmer's doing it for a different reason. You can see all the stones sitting underneath that lentil and bean intercrop. He's wanting to make sure that he can harvest the lentils. One of the challenges with lentils is they're really low to the ground, and if you've got rocks in your paddock, when you come to harvest it, they're going to end up in your header, which is not ideal. So he's trying to put the beans in there to provide a bit of a trellising effect and keep the lentils up so that the header can go through safely. And then the image on the bottom right is of a Canola Pea intercrop. You can't see the peas in there, but I assure you they're under there. And this is a farmer who's been intercropping for 10 years. He's also got another intercrop that we looked at. So his reason for doing it is around soil protection. He has a light soil type that is vulnerable to erosion. He's wanting to maximise soil cover and also provide anchorage over the summer. Pulses tend to break down really quickly and don't often leave a lot of soil cover. The canola, on the other hand, does. So that's just a bit of a snapshot of what the interest is, and that everyone's doing it for very different reasons. So intercropping's a challenging thing to understand until you can see it. So while I give you some more background, I'm going to let you enjoy a bit of a virtual tour of an intercropping site up at Melrose. Thanks to Sarah Day, who works in the team here, for this footage. So enjoy the tour whilst I talk over top of you. So farming systems in the low to medium rainfall zone. So that between sort of less than 350 to 400 millimetre annual rainfall zone in southern Australia. The systems were traditionally focused around mixed livestock and cropping systems. However, there's been this real shift towards intensive cropping systems, and many of these growers don't have livestock in the system anymore. Traditionally, they included a pasture break phase. However, as they've moved to this more intensive cropping system, we're now seeing these systems really heavily dominated by cereals. So a lot of them are less than 10% break crops in their system. So that's a really intensive cereal system. So I guess there's a real need, and it's recognised in these regions, for a more robust break crop in the system in those low to medium rainfall zones. And one of the challenges is the yield stability of break crops in the system. And they do leave some of these landscapes quite at risk of erosion because they don't provide a good amount of soil cover, because they break down really quickly. They've got really fine leaf and stem, and they don't leave a lot of anchoring on the soil surface. One of the other challenges in these low rainfall zones is the variation across season. And going forward, the need to adapt to climate change. So these regions see huge extremes in season to season conditions. So to put it into context, the stuff that you're looking at today was double the height at this time last year. So the biomass was about double what you're looking at. So how do they create a more robust break crop system that doesn't leave them at risk of things like erosion, but also maximises their opportunity to get a return in each season? And so that's why we started looking at these mixed systems. I reckon I've lost a slide somewhere. Oh, this one. So what research I've undertaken. So I did my PhD in pasture cropping in a high rainfall zone, where I was looking at grown crops and perennial pastures. So that was 3 years of research at one location. My work in the low to medium rainfall zones has been over the last 5 years, and at about 6 locations now. The work on chickpea and linseed, or chickpea and canola intercropping, has been done at Hart for the last 2 years. And then last year I dabbled in this frost mitigation intercropping. And through this presentation, I will present data predominantly on that low to medium rainfall zone intercropping, and I'll touch on that frost mitigation intercropping towards the end. The other thing that I've been doing extensively in this space is speaking at field days and other industry engagement. So last year, I spoke at 9 grower group events in the space of 3 months, roughly equating to about 330 growers. This year, I think at the moment, I'm 10 events and counting. So there's certainly industry drive for this information. I guess in context, how does that fit into what's been done at a national and historic level in terms of intercropping research? So in the review that CSIRO did, led by Andrew Fletcher, they found 19 cereal pulse intercrop experiments, historic experiments, but only 15 of those reported yield data. They found 22 pulse oilseed experiments, with 13 of them having yield data available. So that's a total of 41 experiments historically that's been done in this space, but with only 28 of them having yield data. And that total actually includes some of my work too. So as you can see, there's not a massive body of research that's been done on it. A lot of it's been quite ad hoc research and direct funding for intercropping. There has been a funding in Victoria, but that's pretty well it. So this year, what I'm doing is I've continued a small frost intercropping trial at Farrell Flat near Clare. There's a demonstration site at Melrose, which is the one you just had a tour of. And in a GRDC funded project at Toology on the Eyre Peninsula, I've got 2 treatments in a trial that have intercropping. This year was set for monitoring some grower intercrop paddocks. I continue to supervise a PhD student looking at intercrops, and of course all the industry engagement. So the next part of this presentation, that's really all the background I'm going to give you. Hopefully I've given you a bit of a snapshot of what's happened, why we're doing it, and what the interest is in this space. And now I'm going to look and present to you what I've been doing in that low to medium rainfall space, and then I'll touch on the frost intercropping. So this work's been done at a number of sites. You can see this data set includes 9 experiments undertaken in South Australia at Bullaroo, Hart, Roseworthy, Toology, Waikerie, Woodner, through the years of 2016 through to 2020. So I'll explain what this concept of LER is. So we measure productivity gain in intercropping by turning it into this land equivalent ratio. So it is the yield of species 1 grown in intercrop divided by the yield of species 1 grown in monoculture, added to the yield of species 2 grown in intercrop divided by the yield in monoculture. But it is a very difficult thing to get your head around. So the main thing you really need to know is if the LER value is less than 1, the productivity of the intercrop is lower than growing it as a monoculture. If the LER is greater than 1, the productivity is better growing it in an intercrop than growing it as monoculture components. So we're really trying to target LER values that statistically are greater than 1. So we have determined that we use confidence limits to statistically determine over-yielding, and we've concluded that over-yielding occurs when the 95% lower confidence limit is greater than 1. And to make it really easy, I've both marked it with an asterisk and highlighted it in yellow. So as you can see, we're often achieving fairly high over-yielding rates. So a lot of them up over that 20%, and you really, for it to be statistically significant, you're sort of looking at that LER value having to come out at over 20%. And realistically, that's because of the headache involved in growing these systems, that's really where you want to target as well. A grower's not going to want to take on the extra annoyance of these systems without it really having that good return. But not all regions are particularly well suited. Bullaroo, you can see in 2020, which is the first one in the column, there was only one intercrop that over-yielded. That's a really heavy soil type up there. And so interspecies competition for soil moisture suddenly becomes a little bit more of an issue. We also didn't necessarily, or I didn't necessarily, choose the best intercropping pairings in terms of varieties at that site in that season. This is actually one of the first years that I've got field peas to over-yield. And it was some really poor variety selection on my behalf, but that's something we learnt from that. You can see in places where we had a really good season, Toology, which is TOOL 2000, and Warnertown WAR 2000. We really over-yielded well there. So in a good season, these crops do over-yield at a high level. That drops off when we get into our poorer seasons, but we still see them over-yielding. So those who can remember back to years like 2016 and 2017, they weren't necessarily the bumpering years. So I guess that's given us the confidence that these systems do work. We can get them to over-yield, and even with poor variety choice on my behalf, we still managed to achieve over-yielding. So I guess the scientific consensus when I talk to my colleagues is that we know these systems can work from an over-yielding perspective. The pulse oilseed and even pulse-pulse combinations have a higher percentage of over-yielding than cereal pulse intercrops. So productivity gains have been achieved in 14 out of 32 combinations in a range of environments. So we've learned a lot about what combinations don't work. And the highest proportion of over-yielding has been achieved in our chickpea canola, lentil canola, and vetch canola combinations. The other one that's gaining a lot of interest is our lentil faba bean combinations. Whilst things like chickpea and linseed and vetch and faba bean often didn't over-yield in our research. So LERs are one way of measuring intercrop advantage, but may not be the best measure in an unbalanced design. So what I haven't spoken about is for a lot of these low to medium rainfall zones, we're actually targeting the pulse yield, and the canola is in there for secondary reasons, predominantly to try and increase the potting height and harvestability in these systems. So we've actually got this unbalanced combination. So LERs are not always the best way of measuring it. So gross margins increasingly being used to measure and compare the profitability of intercrops compared to monocultures. So here's some results from an gross margin analysis on 6 trials in South Australia on intercrop combinations of chickpea, field pea, lentil, and vetch. So the gross margins were calculated using the farm gross margin guide and the prices accordingly. So the gross margins compared to the sole crops provides a financial measure of productivity of these mixed systems. The gross margins includes the additional seed cleaning cost associated with intercropping compared to the soles. That's important because when you monoculture crop, you don't have to clean out seed. When you intercrop, you harvest it all together and then you have to clean out the seed. So when we look at this, 5 of the 6 trials growing canola as a sole crop were not profitable. Remembering this is our low to medium rainfall zone, we do often see that with canola, we don't always get ideal establishment conditions. With canola in our low rainfall zone particularly, and poor establishment leads to poor yields. Also, they do require that end of growing season rainfall to finish off. So you can see that the monoculture canola is not always our best returns. So when we then look at the sole field pea and the intercrop field pea, they were similar in terms of their return. They were profitable. They were both generally profitable, except in our really, really poor years. But one interesting thing that we've noticed when we do these gross margins is the intercrops often don't lose quite as much money as the sole crops. So that's an interesting thing that we still need to tease apart a little bit further. Sole vetch is a little bit of a flip story. We can see sole vetch has been highly profitable in these sites. That's probably to do with the price of vetch seed. But remembering a lot of these growers aren't growing vetch for seed, so that's a little bit artificial in some ways. So just bear that in mind. So I suppose one of the things to take away from this is that the returns from intercropping are stacking up there with our monocultures. So that's a really positive thing. And we also have this really, really unique thing we need to tease apart as to why they're not losing as much money, which is great, as our sole crops in some of these seasons. And a lot of that will be around input costs, but also having that diversification of income. So you've got 2 different grain crops, they've got 2 different markets, and the prices don't always follow each other. So I suppose that that also demonstrates there is some economic support for choosing to use these systems. But one thing we haven't touched on yet is one reason why growers are targeting these mixed species cropping systems is for an economic return. But a lot of them in the low rainfall zone are communicating with me that one of the big reasons for them adopting these systems is the secondary benefits. So we have tried to look at some of this. We have a much more limited data set around the advantages and challenges of the system's benefits. Sorry. So I guess bear in mind that this is a space where we don't have as big a data set, and there's also a lot of data that I'm still to churn through. So an important factor that's often not considered historically when people were looking at these intercropping trials was to measure those secondary benefits and how we evaluate the potential to reduce costs and manage that market risk. So the chickpea linseed and chickpea canola trials were put in purely for that reason. So a series of 5 field experiments were put in to test the potential to reduce the cost and the risk of chickpea production. So particularly around reducing fungicide applications to control ascochyta blight and moving away from the need to desiccate the canola or the chickpea crop prior to harvest. The other side of it was also looking at reducing fertiliser input into these systems. And that's really been a bit of a focus of the PhD that Alice has been doing in this space. So what we did was set up these trials. We had it designed so we had fungicide strategies and desiccation strategies on some treatment, and then we had treatments where we had no fungicide or no desiccation treatments. So this is likely to be seasonal dependent, but what we found was there was no differences in yield or grain quality of the chickpea seed intercropped with linseed or canola compared to a full fungicide regime and desiccation regime. We were also able to harvest the chickpeas without that need for desiccation. And one of the reasons for that is you get a dry down effect for having an intercrop there. So because they're competing for soil moisture, it was meaning that the chickpeas were drying down as a result of the flax and or linseed and the canola being present in those crops. So we were able to significantly reduce our input costs by intercropping. So whilst we didn't achieve necessarily over yielding in these trials, we significantly reduced our input costs. It is important to note that the 2019 and 2020 seasons were not conducive to severe disease. We did get disease in there, but it wasn't severe. And more experimentation would be required under different conditions where we did have high disease loads and also wet finishes. The other thing, and this is really around Alice's work, is there was no differences in grain yield of linseed chickpea intercrops under a nil fertiliser regime compared to a high N and high P. So we're talking 50 kgs of N and 20 kgs of P per hectare, suggesting that intercropping could facilitate reduced fertiliser input. Again, that's going to need more work, but it does look like some of the benefits of these systems can be around that reduced input costs, particularly around our fungicides and our fertiliser. Some of the other secondary benefits of intercropping that are reported included our rotational benefits. So things such as nitrogen fixation, environmental and soil health benefits. So we've got some data on this, and we've got more data that I haven't had a chance to fully tease apart yet. But just looking at WRI in 2017, we did some baseline measurements preceding, and then again post-harvest we came in and looked at nitrogen levels in the soil. So the baseline nitrate N was 2 milligrams per kilogram at the start, and you can see there the left axis is the measurement of nitrate N milligrams per kilogram taken immediately post-harvest. So what we can see there is no surprises that sorrel, vetch, field pea and lentil all had the highest rates of nitrate N when measured post-harvest. And then we can also see that sorrel barley and sorrel canola pretty well were at the same levels at the end of the season as what they were at the start. So the amount of nitrogen we provided the crop was sufficient for its needs. Interestingly, we had canola in all three of these intercrop treatments, so field pea canola, vetch canola and lentil canola. And you can see that whilst they didn't achieve the lofty heights of the soil treatments, they certainly were providing some benefit back into the system. There was no additional nitrogen applied to those crops. So they had MAP fertilizers supplied at seeding, low rates of MAP. So off the top of my head, I think it was 50 kilos of MAP applied at the start of seeding. And all the remaining nitrogen supplied into that system was done by the pulse. So it does look like these systems can still provide some nitrogen benefit to the system, not the same level as obviously the sole crops, but they're not causing a depletion. So again, there's a lot more data to tease apart than that, and I just need some time in the office to do so. So that's a good start to that story. The other thing, and you can see why some growers are really looking at these systems. Again, Sarah is a bit of a photographer in our team, and she took a very poignant photo in 2018. So this is on the 30th of August. At this time of year, we would not expect to see dust storms. There should be full ground cover at the 30th of August. Anyone who can remember driving around in 2018, it was pretty horrendous. So one of the big drivers for these systems is that soil cover. These are quite fragile soils through the mallee of some of our sands. And so what we looked at in 2020 was we used photography and being able to extract green image through photography, looked at ground cover, early season ground cover. That's a really good measure for these regions because they want early season cover and they want to achieve full ground cover. So you can see here things like sole chickpea, sole faba bean and sole lentil are pretty slow to achieve ground cover. So on the 24th of June, they were sitting at 30 to 35% ground cover. Once we start then intercropping some of those, so we can see at the far end of that table, vetch and faba beans, we're up at about 70% ground cover. So we know these intercrop systems do achieve ground cover quite quickly, especially with those species that are pretty poor in terms of their ground cover, like chickpeas and faba beans. So I think we're starting to build up a bit of a story that these systems have productivity benefits, they've got economic benefits, and they also have some secondary benefits around those break crops, nitrogen fixation and ground cover. So I'm going to touch pretty briefly on the results from a completely different region, and that is intercropping in frost-prone environments. So this work, one of the challenges of growing pulses in frosty environments is they're not overly tolerant to frosting. They're very tolerant to frosting prior to going reproductive. So unlike cereals, it doesn't bother them too much to get frosted in their vegetative phases. However, they are very susceptible to yield penalties and damage when they get frosted in flowering and potting. So growers in this region really have one pulse option, and that's faba beans. And even that gets frost affected, and they can receive some pretty significant downgrading in terms of that grain because it's a food grade visually assessed product. So they want more pulse options for their region. So what we looked at was, could we use plant architecture and the structure of intercrops as a frost mitigation strategy? So could we grow our most vulnerable in terms of frost damage pulses, lentil and vetch underneath a canopy of wheat or faba beans or canola? So that's what we did. We had the trial duplicated across 2 points in a landscape within the same paddock. So one on the lower part of the paddock, so really frost prone, and one more on the upper part of the paddock, which was still frost prone, but the severity is not normally as bad. So there were duplicate trial sites. We also, in addition to our standard agronomic measurements, we had temperature loggers installed at 2 heights in each plot, and those were targeting the canopy heights at flowering and podding of the respective species. So they were set at 30 centimetres and 90 centimetres. All up, we had about 670 sensors out there, logging every hour from June to November. We also wanted to catch the heat stress events. So in 2020, across the growing season, we had a total of 58 frost events. 13 consecutive days of frost were recorded in July and the beginning of August, where the temperatures were below 0 degrees Celsius, which included a frost event that was minus 5.3. So that gives you a bit of an indication of how frosty these environments are. However, for this particular trial, there was one frost event that proved the most damaging. It was a single frost event at the end of September, and this was during the podding period for the pulses. So in this slide, you can see the amount of damage that that one frost event caused. It was about 6 hours in duration. It wasn't massive in terms of, it was probably sitting about that -2, -3 degrees. But you can see on the left there, that's vetch, and it looked like someone had gone across the top of the plot with a blowtorch. I've never seen anything quite like it. Every single pod was damaged, from the top of the canopy to the bottom of the canopy. In the middle there, you can see the lentil pods damaged, and even our faba beans didn't escape it. So you can see the sort of damage that that one frost event caused. For me, from a research perspective, it was amazing. I had to be careful saying that to the growers, but it was amazing because I could attribute all that damage to one event, which also was very helpful when extracting the information from those data loggers. So we could see that there were quite strong visual differences in the amount of frost damage. And we scratched our heads because this is very new research. No one's ever done this before. How were we going to capture that? What we did was we went out and sampled 5 vetch or 5 lentil plants from each of the intercrop combinations, and we counted all the pods as to whether they were frosted and viable, frosted and non-viable, or there was no frost damage. There was not a single pod in those assessments that were not frost damaged. To put it into perspective, that was 180 man-hours of work to investigate just that one measurement. So these are really labour-intensive trials. And you can see there the visual effect that we were seeing in the field. So on the left-hand side, you can see the intercropped vetch, and on the right-hand side, the sole vetch crop. And if you look really closely at, you can see the pods are still full on the left-hand side. Some of those pods, you can see there's still grain in there, whereas the frosted vetch on the right-hand side, you can see how black and darkened and flat those pods are. So what did it mean, those 180 hours of excruciating pain? And believe me, I wasn't popular. This is what we ended up with. So this is the percent of frosted non-viable lentil and vetch pod at the lower site, which is our more frost-affected site. And you can see the error bars indicating the standard error of the mean there. So the higher the number, the worse the impact of the frost. So the higher the number on the of the columns, the worse the impact of the frost was. What was really interesting here was you can see the monoculture lentil and vetch, they were sitting at over 80% damaged pods, non-viable pods. What was really exciting was that we actually did capture the benefit of the intercrops, and we can see for some of those combinations, whilst there was still a lot of non-viable pods, we did actually retain more viable pods in the intercropping treatment. So that was really exciting. But that's all well and good because the plants were able to actually recover and continue flowering for a brief period post this frosting event before senescence. What happened to the yield at the end of the day? So this is what happened. We can see here there was distinctly a different effect between the top site that was less affected by the frost event and the bottom site, which was more severely affected. So at the top site, we can see there that the vetch treatments are in yellow, the lentil treatments are in blue. Both the sole vetch and the sole lentil out-yielded the intercrop treatments, purely just looking at the lentil and vetch yields on their own. We haven't there added in the component yield of the canola or the wheat. But you can see that it's still promising once we add in the other crops and also less damaged grain, so less likely to be downgraded. There might still be some benefits for them doing it in that part of the landscape. Then when we go down to the bottom part of the landscape that was a lot more frost affected, we can see that in the vetch, the intercrops actually, where we had wheat, canola and vetch, out-yielded the sole vetch. And in the lentils, we can see some of the intercrop treatments yielding the same lentil yield as the sole lentil. Again, bearing in mind, we haven't actually added to any of those that second component yield of the canola or the wheat. So I guess this was really exciting for a first year's result, and it's gained a lot of interest in this area. The other thing that we looked at is this region also cuts a lot of hay, so we did look at the biomass yields, and generally the combined, there was no differences in biomass production for the treatments on the upper site, so that's useful for a hay crop if they wanted to go that way. There were differences in biomass production on the lower site treatment, the frosty one, where the most notable ones are the sole vetch and the sole canola are all lower than the other treatments. So it's creating a lot of interest. It's 1 year's result, so we'll see how it goes from here. So I'm just going to briefly now touch on some of the challenges, the logistics, and one of them is harvest. So you're harvesting 2 grain crops together, which is a bit of a headache in terms of how you set up equipment, but then you can see the photos below how you clean that out. So we've been able to demonstrate all the benefits of it, but some of the barriers still exist to broadacre adoption, and that's the complexity of the agronomic management. Some of these are being overcome now. I won't go into all the details of that. That's probably more of a conversation I have with growers. But we are starting to be able to overcome some of these logistical challenges of seed cleaning, particularly. You can see here we visited a seed cleaning plant. This is an on-farm seed cleaning plant. So some of the others are around harvestability, and you can see this one where I'm shaking it here. The peas are quite nicely attached to the lentil crop, and come harvest, the peas will drag the lentils into the header front. So they're going to achieve a higher harvestability in that combination. So a lot of the challenges are being overcome, and that's a space where working with growers in that peer-to-peer learning space is going to be important to further adoption of these systems. So that's all. Thank you for listening, and hopefully we've got some questions.
Thank you very much, Penny. If people can type some questions in the Q&A box, that would be great. I know we have a couple in the chat box already. So from Katja, Did anybody look at pollinators? Extra foods may lead to higher presence in fava beans and canola benefit from better pollination.
Yes, and that is a fantastic question. The answer is no. I do have a staff member on site who is very keen to look at the pollination aspect of some of these. She was fortunate enough to do her PhD on native bee pollination. So it's a space that we would like to explore further, because particularly for some of the farmers in that regeneration ag space, that's something that they're pretty keen to know. They want to know is what, not just pollination, but do these systems attract more beneficials into the system, and is there then less need to be spraying out pesticides? So very good question. Short answer, no. Longer answer is we'd really like to look at it.
A couple of the logistics questions from Paul Petrie. How do you go setting up the combine to harvest seeds of quite different sizes? And are there problems with dressing the seeds to separate them when they are similar sizes, i.e. lentils and grains?
Okay, yes. Setting up the combine isn't too bad. You set up the combine. So say it's a pulse and a canola, that's actually really easy to set up, and you can get some really good samples off of that. You do end up with the grain all mixed together, but you basically set the header up for the pulse, and even keeping the wind speed up, you don't blow too much canola seed out the back. So it's actually not too bad. And because you have a bit more trash flowing through, a lot of the farmers are reporting that they do have to slow down, which they don't like doing, but the harvestability is actually a bit better because you're bringing in a little bit more to the header front. So the thrashing ends up being a little bit better. The second part of that question is cleaning up grain. That is a bit of a headache more than a problem. So they've got to have on-farm grain storage, and for some combinations, they have to clean it quicker than others. So where it's a pulse and a pulse together, you're harvesting at the same moisture content. So you're harvesting pulses at the same moisture content across all pulses. So having them mixed together post-harvest doesn't really matter. The growers will just dump them into a field bin or into a bulker type storage system and just leave it there till they get around to cleaning it. Canola pulses are a little bit different because you're harvesting them at different moisture contents. So there is a question around how long you can leave them mixed together before there's potentially a moisture draw from the pulse to the oil seed. There's a lot more seed cleaning plants now available to growers, and that's why we're probably, one of the big reasons why we're probably starting to see a little bit more adoption of intercrops is because we're overcoming that harvestability and seed cleaning logistics. The other big one is weeds, managing weeds in these systems. We now actually have Group B herbicide tolerance in pretty well all of our crops bar vetch, and so combining them together, we can get in-season weed control. I can see the question there from Phil. Do you plan to investigate pest and disease response in monoculture versus intercrop combinations? Yes, we do. Again, the longer answer is, and I think I alluded to it earlier, that I've never received any direct funding for this work. So it's all been very ad hoc. And my hope is that I've been pushing to try and get funding in this space for over 10 years now, that eventually someone's going to get sick of me asking and just give me some money to do it properly. The priorities, if that was to happen, would be around that pest and disease response and quantifying those secondary benefits, particularly the soil benefits of these systems. Oh, Sorry, I think you're on mute and I can't.
Sorry. Okay,
Yeah.
sorry. I had someone talking to me in the background. Does anybody have any more questions for Penny? If you have, type them in the Q&A box really quickly. Otherwise, I would like to really thank Penny for her really interesting presentation on a new topic for many people, and obviously something that the farmers are really interested in. So thank you very much for your work and good luck with getting some funding. Thank you.
Thanks
everybody.